So this 3D model itself is a really good representation because it is, well, a perfect representation of the engine compartment. So our engineering team was actually able to take this as an input, and then from there we were adding components. So the bus itself is essentially fully built currently in 3D in CAD.
That virtual bus was created using LiDAR technology to scan the entire structure, including the engine bay, to overcome changes in original measurements from general wear and tear over the life of the bus, and to ensure accuracy in the conversion.
The structure in the back, even though it should be spot on, might be off by a centimeter, which is huge when you're actually going through integrations like this. So for us to actually have fresh CAD scans of the bus itself that's been in service for a good part of its life, things are going to shift, things are going to change. So that gave us a really good, exacting view of where the bus sits right now for us to integrate our parts into it.
And that means the diesel to electric switchover is at a turning point. As Menard describes it, we have the recipe, and now we're going to start putting it together.
We've already incorporated some of the mechanical components that previously ran off the diesel engine. So these are going to be items like the air compressor, the power steering unit. We have the heater involved. We've also integrated partially the battery thermal system that's going to be going onto the roof itself. Unique thing about these is the design of them kind of mimics IKEA's flat pack philosophy. They're a smaller rectangular shape that allows us to stack many of them in really small, awkward spaces.
This is the first time that we've ever been part of working with a vendor or a supplier to work on this type of unique project, looking at a lot of the images and trying to find different ways to solve problems like where batteries will go on the buses and things like that.
Those batteries, and mostly the flat pack technology, are one way to relate such a large project to the average electric or hybrid family car. The bus will also be equipped with regenerative braking.
So when you let off of the pedal, much like in a Tesla or a Chevy Bolt, whatever it may be, the bus itself is going to regenerate. And we can actually program the severity of that or the intensity of it. So if your driver's driving along on the highway at 80 kilometers an hour and lifts off the pedal, it's not going to jerk the passengers forward. It's going to have a more linear approach to it. So this is going to allow them to have one pedal driving, but also increase the efficiency of the bus. So it's going to increase the range of the bus as long as the driver goes through and utilizes this one pedal driving.
Although there's clearly still a lot of work to do, the crew at MTB are anticipating turning over the ignition for the first time in just a few weeks.
We are hoping to have the first turn on of the bus going to be in early November, and then from there just quick testing. That's going to allow us to do some troubleshooting with the electrical system and then just testing the bus as it runs through.
As soon as we receive the vehicle, then we will do our own testing, and we want to throw it into a number of different scenarios where, will it be on a different route with lots of loads, different types of loads, where we would put water barrels and things like that to replicate passengers on a vehicle. We want to put it in different routes and settings and climate to get an understanding of what the battery will do and how long will that battery last.
D'Alessandro says the town will likely put the bus through its paces all winter, and if everything goes well, incorporate Milton's first electric conversion bus into regular service in April of next year. Jason Trout for Halton News in Milton.